In this video, we're going to learn how to plot an ellipse in Desmos, the online graphing calculator. Now, an ellipse is a shape on the XY coordinate axis plane that has an equation that looks like this. X squared over a squared plus y squared over b squared is equal to 1. And now we don't see anything yet, and that's because we haven't yet added sliders. So let's add sliders here. And let's zoom in just a bit. And so what we see is that when A and B are equal to one another, in other words, when A is equal to 1 and B is equal to 1, we have a circle. Well, what this means is that an ellipse, or rather a circle, is a special case of an ellipse. So ellipses and circles are related to each other. Now, in the rest of this video, we're going to use specific numbers to plot our ellipse. And the numbers that we're going to use come from this chart. Now, this chart is a chart of Pythagorean triples and their squares. Now, Pythagorean triples are groups of 3 numbers that obey the Pythagorean theorem. So we're going to use this particular set of triples. It's 24, 45, 51. The squares of those numbers are 576, 2025, and 2601. So these are the numbers that we're going to be using in the rest of our video. So let's go back to Desmos, and we can get rid of these sliders. And let's get rid of a squared. And we're going to write the largest of those 3 numbers, of the squares of those 3 numbers, which was 2601. And then we're going to go over here to the other denominator. And we're going to use 576, which was the smallest of the squares of those 3 numbers. Okay, now in our Desmos window, we don't see our ellipse yet, and that's because we're zoomed in too close. We're actually inside the ellipse. So we're going to back out a little bit by zooming out. There, and there's our ellipse. Now notice that in this ellipse, the longer axis is the horizontal axis. In other words, the one that lies along the horizontal x-axis. Right, and that's because the bigger number is underneath x squared. 2601 is a bigger number than 576. So when the bigger number is under x squared, then that means that the longer axis is going to lie along that horizontal line. So let's plot these points. We're going to write them down here in Desmos. The first one is 51, 0. And the second one is negative 51, 0. Okay, and let's make both of those black. And in fact, let's increase their size to 15. So we're going to do the same with this one. It's already black. There we go. And then let's change the size of that point to 15. I know that those are kind of large, but here's what we need to notice. Okay, so let's label those. Okay, and these points are actually something that is known as a vertex. Each of them is a vertex. So this first one, we'll call it a vertex. And let's, again, write down the coordinates of the point, 51, 0. So that's a vertex. Okay, and the other vertex that we have is the one over here on the left, which we're going to label as a vertex, and it's going to be negative 51, 0. Okay, so, and please keep in mind that 51 squared is equal to 2601, or in other words, the square root of 2601 is equal to 51. And that's where we get these points from. Okay, so these are the first 2 points. that we're going to be concerned with. And we're actually concerned with the line segment that joins those 2 points. So here's how we can make a line segment on Desmos. We're going to make a polygon, but our polygon is only going to contain 2 points. It's going to contain the point 51, 0, and then also the point -51, 0. Okay, and we're going to make that black. And let's turn that into, we'll make that a thickness of 6 pixels. Okay, so that is our major axis. That is our major axis. So let's draw a major axis on here. We're going to draw an arrow. Okay, and the arrow is going to point at that major axis. And then we are going to label that as the major axis. Put it right here. Okay, that's the major axis of the ellipse. Okay, now that's not the only points that we're going to be concerned about here. We're also going to be concerned about these points up here and down here. Okay, 0, 24 and 0, -24. So we'll plot those. 0, 24 and 0, -24. So we're also plotting those. And let's turn those into red. And let's make our points have a size of 15. Okay, so that's that one. And we'll do this one as well. So those are our 2 points. Now, those 2 points are the endpoints of the shortest axis of the ellipse. Okay, and so let's label what those points are called. Those are called co-vertices, or each one individually would be called a co-vertex. So that's co-vertex, and that first one's going to be 0, 24. So there is our co-vertex, 0, 24. Okay, and then our other one we're going to call a co-vertex also. And it is 0, -24. Okay, and in actuality, I want to make those green. I don't want to make them red. Try that again. There we go. So there's green. And there's green. Okay, and so those are the co-vertices of the ellipse. And we're going to make another polygon. And this time, the polygon is going to have those endpoints in the polygon. So the first one is going to be 0, 24. And the other one will be 0, -24. Okay, and we're going to change the color to green to match the endpoints. And we're going to increase the size of the line to 6. Okay, now that is the minor axis of the parabola. The co-vertices are the endpoints of the minor axis. So we're going to label that. And we're going to make it green, our label. So we'll put it up here. And we're going to draw a line, and excuse me, that one is too thick. There we go. Okay, and we are going to call that our minor axis. Okay, so our major axis was in black, and our minor axis is in green. Now, those aren't the only points that we're concerned about here on our ellipse. All right, we're going to add two other points. Now, hopefully you recall that in our Pythagorean triples, we had three numbers, and those numbers were 24, 45, and 51. So we've accounted for two of those numbers from the Pythagorean triple. This time we're going to use 45. So let's plot those points. So the first one is going to be 45, 0. And then the second one is going to be negative 45, 0. Okay, and let's label those. Well, let's change their color first. Okay, let's make those purple. And we're going to make that stand out. It's going to be 15. So there's the first one. And the next one will be purple. You know what? I prefer blue. Let's do blue. And that's going to be 15. And let's go back and change the other one to blue. Like that. Okay. So we're going to label those also. So we're going to call this first one a focus. And that's 45, 0. So that's the first focus. And then our second focus is negative 45, 0. There we go. Okay, so we have the major axis and the minor axis. We have the vertices. We have the co-vertices. And we just plotted the foci. And foci is the word for the plural of focus. Okay, now there's one more point that we're going to plot. Okay, and that is the center, which in this case is at 0, 0. Oops. There we go. And we're going to label that as center. There we go. And we labeled it as the center. And we're going to turn that color. Let's turn that into orange. And we're going to make that size 15 also. Okay. So so this is the way ellipses work, right? We can plot any ellipse so that they have integer numbers for the vertices, for the co-vertices, and for the foci if we use Pythagorean triples, right? Pythagorean triples are really handy because they can give us integer results for these numbers, okay? And so you can see where each of these points belongs. In future videos, we'll discuss what each of these points mean, and hopefully you find this helpful. So until next time.